Hi, for this presentation, I will introduce my study, Information Theoretic Analysis of Price Dynamics in Future and Spot Markets. This study is a focused case analysis involving the Chinese pork spot market and the LH Linhong 2405 future contract. In my analysis, I will use two key information theoretic measurements, mutual information and transfer entropy. The tool I use for this study including MATLAB for data processing, GIDT for entropy calculation, and Wine Financial Terminal for searching the data. Let me begin by introducing the research focus and our dataset. The main research question we explore in this study is, how does information transfer occur between spot and future price? The data we analyze consists of Chinese pork spot price and the LH2405 future contract. To be specifically, the spot price represents the daily pork price in China, which was sourced from Wine database, with a unit in yuan per 500 grams. The future contract, referred to as LH2405, is a daily closing price for Linhong futures, as covering a period from May 2021 to January 2024, which provides us with 620 trading days of data. The data we obtain from Wine, which is a well-known financial data provider in China. The objective of our research is to understand the price transformation between spot and future markets. For this purpose, we utilize information theoretic measurements like mutual information and transfer entropy, which allow us to capture the shared information and the directional influence between those price series. Here you can see a plot of the normalized time series for both spot and future price across entire data periods, which give an initial overview of how those markets moved together or divergent during this time frame. From these slides, for simplification, I will just say LH2405 as future price. Now, let's move into the mutual information. Mutual information is a symmetric measure that quantifies the shared information between two variables. It helps us determine how much knowing one variable reduces the uncertainty of the other. Here, we are particularly interested in how much the future price and spot price reveal about each other, especially at different time delay. In this study, I will focus on two equations. The first one, mutual information between future price with spot price when delay happens in future price. The second equation is mutual information when delay happens in the spot price. This helps us understanding whether information flows more promptly from futures to spot or spot to future over time. To calculate mutual information, we use KSG estimator with K to 10 nearest neighbors. This estimator is ideally for continuous varied data like financial price, as it efficiently balances between bias and the variance in the estimate. I varied the time delay of the sort from 0 to 40 to explore potential lead-lag relationship. The comparison plots showing mutual information value between spot and future in both directions over time delays. It reviews how the shared information changes, helping identify significant time lag effects in the market. An important observation here is that on average, mutual information spot to future is greater than mutual information from future to spot. This suggests that the spot market might play a leading role in the information flow. We also identify key time delay, for example, lag 15 and lag 33, where mutual information is significantly higher. This indicates periods where there is a stronger information transfer, suggesting we might need to see the local information in those delay time. Finally, the statistical significance of mutual information value was confirmed with a p-value of 0, meaning the results are not due to random fluctuations. Let's take a detailed look at the local mutual information analysis. Local mutual information measures the shared information at specific points in time between spot and future price. It gives us a more detailed view of how those two markets interact in the specific time delay. In simple words, it matches day price to day price. In this study, we focus on visualizing K time, lag 15, looking at how past the future price 15 days ago are relative to current spot price. Lag 33, looking at how past the spot price 33 days ago affects current future price. So what did we find? The scatter plot shows stronger connections, high local mutual information value during periods of extremely high or low price. This means that markets are more linked during time of major price changes. The time series in the right shows how those connections are strong, indicated by the red areas and the blue areas in the scatter plot. Local mutual information helps us see where the spot and future markets are mostly connected. The connection is especially strong during extremely market conditions like very high or very low price. Future price seems to be a good predictor of spot price, especially during those extreme conditions. On this slide, I'm going to discuss transfer entropy, which helps us understand the direction of influence between spot and future price. Transfer entropy is an information theoretical measure that tells us how much knowing the past state of one price can help predict the future state of another price. Essentially, it helps capture the directional influence between the spot and future. We use the KSG estimator with k equals to 10 nearest neighbors, which is effective at balancing bias and variance. Additionally, we set a dynamic correlation exclusion window of 5 and history parameter k equals to 2 and L equals to 2. Those settings help ensure transfer entropy results are not biased by short-term correlations. Then we calculate the transfer entropy with time delay from 0 to 40, looking at how will past information from either the futures or spot price help predict the other. From the plot, you can see the transfer entropy from spot to future is generally higher than transfer entropy from future to spot, which implies that the spot market tends to lead in terms of providing information useful for predicting future price. For key result here is the average transfer entropy value from spot to future is consistently higher, suggesting that the spot market plays a more significant role in price discovery, and all the results are past the significance test. On this slide, I'm going to discuss how both mutual information and transfer entropy help us understand the relationship between the future and spot market, and how this aligns with economic theory. Starting with the result, we can see that both mutual information and transfer entropy are higher for spot to future compared to future to spot. This means that the spot price leads and contains more useful information for predicting future price movement. This supports the idea that the spot market plays a primary role in price discovery, meaning spot price moves first and the future follows. The stronger coupling from spot to future highlights that the future market reacts more to changes in the spot price rather than leading it. The asymmetry in the information flow between spot and the future suggests that while information flow both directions, the influence from spot to future is stronger, indicating that the spot market is better at reflecting underlying fundamental changes. Finally, the market behavior insight. This implies that during this period, market participants are more responsive to spot market changes, making the spot market a better indicator of overall market trends. We also consider future work, such as looking at linear correlation or investigating local transfer entropy value to better understand the dynamic in different periods. Moreover, consider extending the analysis to other commodity and other future and spot assets is important. Thank you for listening. This is the end of my presentation.